All right, so yeah, this is 1.4, Math 9 1.4, question number 3A from your textbook. It says determine the surface area of each composite object, give the answers to the nearest whole number, and this one is a cylinder on a cube. So we've done lots of examples like this, so you should have an idea of what you're doing. I'll do this the same way that I did all the other ones so that hopefully this makes a lot of sense to you. This is the same question really that was in the notes, except the one in the notes was turned sideways. So this one, if you look at your notes, you turn sideways, it's the same picture. All right, so what I'm going to do is I'm going to account for the surface area of this circle that's on top, that's exposed. I'm going to account for this wraparound area, and I'm going to account for all 6 of the sides of the cube. So 1, 2, 3, 4, 5, 6. Okay? So I've got 1, 2, 3, 4, 5, 6, 7, 8 sides in total. And then I have to subtract the part of the top surface that that's not exposed anymore. And that just happens to be the same as the circle on top. Okay? And some of you already are saying, hey, I'm not even going to count the circle on top because I have to take it away later anyways. I'm totally fine with that. I'm going to do it this way, counting all of the surfaces that are exposed to the air and then subtracting anything that's covered up later. That's the way I do it. I think that's the way that it's easiest for those that are maybe unsure about this, okay? So, again, here we go. So the area of the circle on top, okay? The circle on top. That's going to be pi r squared, and I will write the formula there, and then I will please fill in the values for any of the variables in the expression. So 2 centimeters, is that the radius, or is that something else in this diagram? Yeah, it's the diameter, right? So the diameter is 2 times the radius. So that means I have to divide this by 2 to get the radius. So diameter is 2 centimeters. The radius is just 1 centimeter. So I'm going to square 1 here. So really, this is just pi, or 3.14159. You see that? Pi times 1. So that's the area of the circle on top. Check. The area of the wraparound part, let's say this is area 2. That's going to be, who remembers the formula for the wraparound part of a cylinder? Just shout it out. 2 pi r h. Right, there's no squared in this one because it's really just a triangle, a rectangle, right? When you cut that cylinder up and you flatten it out, it's just a rectangle. So there's no pi, there's no squares. It's just 2 pi r h. So that's a good one to remember. So let's fill those values in. That's 2 times pi times r, we said was 1 from before. And h is, the height is 4. Very good. So that's going to be 8 pi. And yes, you can use your pi button on your calculator. You should have a scientific calculator that has that. So I'm just going to do 8 pi. And that as a decimal is 25.13. Okay, so I'll just highlight my numbers that I've got here so far. Everybody doing okay with this? Yeah? All right. Okay, let's move to the cube. Now, the cube has 6 identical sides, so that's great. I'm going to say, the cube here, okay, the area of the cube. And we'll do this all in one step because they're all the same. So I'm going to go, one side is 4 times 4, right? 4 times 4 is an area. And there are 6 identical sides because all 3 dimensions are equal. That's the definition of a cube, okay? So I'm going to go 4 times 4, and then I'm going to go times 6, because there's 6 of them. So we'll do this all in one step. So that's going to be 4 times 6, or 96 square units, okay? All right, I'm getting close to being done here. The only thing that I have to do is remember that in finding the area of this top one, which I did in here, I've counted the circle that's covered, and that's not good because it's not a surface. So it's covered up. So I need to subtract, and I'll do that in red here. I'm going to subtract the area of this circle, which is this one, right? It's this. This is the circle I need to subtract now. So minus 3.14159. Okay, we counted it on top, and that's great, but we have to subtract it from the surface on top of the square. So I have to subtract it. Okay, does that make sense? Does that look right? You guys okay with that? Is there a question over there? Are you okay? Okay, so we're counting this, we're counting the wraparound part, we're counting the cube faces, and we're subtracting the covered up part. So let's do that. Area total is 3.14159, and then I'm going to minus that right away, 3.14159, and then I need to add 25.13, and then I need to add the 96. So these two are canceled out, and 96 plus 25, that's going to be, what is that, 121.13? Yeah, is that confirmed? Let's see, 25.13 plus 96, 121.13. And we got to make sure we have our units in there, which the units of length are centimeters. So because it's an area, it's centimeters squared. Okay. Now we'll just double check some things. Okay, so I usually ask for 2 decimal places. That's a good habit in math, but the textbook did say you can round it to the nearest whole number. So the answer in the back of the textbook would be 121 centimeters squared. Is that correct? Yeah. All right, awesome. Okay, excellent. Any questions about that at all? That one should be pretty easy. If you're struggling with that question, okay, you need to come talk to me. You need to flag me down. I need to help you with something. If you don't understand that, you need to understand that kind of question at this point, okay? And now we're just practicing. You're just practicing keeping your work in order. You're practicing punching the numbers correctly in your calculator. You're practicing, getting the right units, rounding things correctly, and so on. All right? All right. Okay, here's the next question in the textbook. Again, very similar to the top one, except this composite object is just turned over on its side. So everything's going to be very, very similar. This is not a cube, but why don't you go ahead and try 3B on your own and see if you can get 3B, and I'll show you the answer that I got in a minute here. Okay, so how I would go about this is exactly the same way as we did the first one. This is a diameter because it has the little arrow going from the edge of the circle to the other edge of the circle. So the radius here is actually 0.5 centimeters, okay? So you got to take that into account. So the area of the circle on top is going to be pi r squared, which is pi times 0.5 squared. So 0.5 squared is 0.25. So 0.25 times pi is going to be, delete, times pi is 0.78539. So 0.78539. Yeah, we're going to round to 2 decimal places, or actually the whole number. So I would suggest keeping more than 2 decimal places if you can. It's not a 100. If you round to 2 decimal places for this question, you'll be totally fine. But I like, and again, I teach the upper level math classes. Keep as many decimal places as you can during the question so you can round properly at the very end. So that's why I write a lot of decimal places. Okay, so that's the top one. Okay, the wraparound part, so that's area 2 here. That's going to be 2 pi r h. Okay, which is 2 times pi times the radius of this circle we said was 0.5. And the height of this cylinder is 3. Now I know it's a sideways length, but that's just because it's tipped over on its side. So don't get mixed up. This is the height of the cylinder, okay? Even though it's a lateral length, it's sideways, it's the same as the height. Okay, so 2 times 0.5 is 1, times 3 is 3 pi, so let's just do 3 pi in our calculator. 3 pi, 9.425, 0.425 or so. Okay, so that's great. We'll use this number, we'll use this number. And now I have to look at the rectangles. So I'm going to do the rectangles in blue here. The front side is going to be 3 times 6. Now, is there another side that's similar to the same as this one? let's see here. 3 and 6. What about the backside? Would it be 3 and 6 as well? Yeah, the backside would be 3 high and 6 wide as well. So guess what? I'm going to do 3 times 6 times 2. You can shorten this up a little bit if you want. So 3 times 6 times 2. That's going to be the front and the back. And what's that? 18 times 2 is 36. Okay, so that's front and back. So let's do area of the top and bottom. Okay, top and bottom. That's going to be, I'll do that in black, 4 times 6 times 2. So 4 times 6 times 2 for the top and the bottom. So what's that? 48. Okay, so 24 times 2. Awesome. And let's do the area of the sides now, the 2 sides. So that's going to be 3 times 4, right? For each side. So 3 times 4 times 2. That's 12 times 2 is 24. Okay, so I've added up all the surfaces of the 2 separate objects. Well, almost all of them. I didn't add the circle for this bottom of the cylinder because it's covered up. So what do I have to do? I have to subtract something here, don't I? Is there something that I've counted that's actually covered up? Yeah, it's the bottom of the cylinder here. So I've actually counted this whole surface on the side here by doing 3 times 4. But I need to take away this little part because it's covered up. So I'm going to minus the area of the circle that I counted before. So I'm going to minus 0.78539. Okay, so area total here now is going to be this one and this one. They cancel each other out, so I'm not even going to write it out this time. I'm not even going to write it out. So I'm going to go 36 plus 48 plus 24, and then I don't want to forget this guy right here, plus 9.425. So this one, this one, this one, and this one. And what's that going to be? We'll add that up. So I'll leave this big decimal on my calculator screen. That's great. I'll just kind of keep going from there. So plus 24, plus 48, plus 36. 117.42, or to the nearest whole number, that's 117. And that's going to be centimeters squared. How about that? Does that agree with anybody else that did that already? Does that agree with? Okay. Is that what the back of the book tells us? Should be the answer. All right, so 4B, it says a cylinder. So there's a cylinder in between 2 rectangular prisms there. So this one, what we want to do is you want to look at sort of this rectangular prism separately, this rectangular prism separately, and then the cylinder separately. Now the cylinder, both ends are covered up, right? They're not exposed, so we don't have to add the ends of the cylinders at all. What we will have to remember though is we'll have to subtract the area of the circles at the end of the cylinders. We'll have to subtract those twice. So we can do everything separately and individually. We just have to subtract the surface of the circle surface area twice because there's a section out of this square and a section out of this rectangle. Okay, so let's go ahead and do that. So area 1 here, this is going to be 1.5 times 1.5. That's a square end, right? That's a square end, and there's 2 square ends. So area 1, let's say that's the ends. So we're going to go 1.5 times 1.5, and there's 2 of them, so we'll multiply it by 2. So that's 2.25, that's 4.5, I believe. That's the 2 ends. And the top is 1.5 by 2.5, and so is the bottom, and so is the side. So we've got 4 equal sides. So area 2 would be the sides, and that's going to be 1.5 times 2.5, right? That's the area of this side face, but that's the same as the top, and same as the back side, and same as the bottom. So we can do times 4 there. So again, that's this front face all the way around, front face, top, back, bottom. So 1.5 times 2.5 times 4, what's that one going to be? Whoops. 15? 1.5 times 2.5 times 4 is 15 exactly. Okay. So 15 Whoops, I'll do that in blue. 15. Okay, so I've got 4.5. I've got 15. Now let's move to the other rectangular prism over here. I'll do this one in black. So the area over here is a cube. Oh, that's easy. 2.5 squared times 6, because we've got 6 sides on the cube. So that one's really easy. So that's 6.25 times 6. Let's see, 2.5 squared times 6. 37.5. Okay, now the wraparound part of the cylinder. So let's do that one in we got black, blue. Oh, let's do a green. There we go, green. Okay, so the area for the middle one, the cylinder, is going to be the wraparound part. So I just need to do 2 pi RH, right? And what is the R here? Let's see. What do they tell us? The cylinder, oh, diameter of 0.5. So the R is going to be 0.25, isn't it? Half of the diameter, is that right? So the height is 3.5, so this is 3.5 here, and then the radius is 0.25. So 2 times pi times 0.25, that's the radius of this circle, times 3.5. And that's, again, that's just going to be this wraparound part. So I'll jump on the old calculator for this one. That's going to be 2 times 0.25 times 3.5 times pi equals 5.4977. 5.49778, I guess. Okay, so I'll leave a bunch of decimal places there. Okay, so we're getting close, aren't we? What did we say at the beginning, though? We have to subtract 2 areas of the circles because they're covering up a piece of this face and they're covering up a piece of this face. So we need to subtract those areas from the surface. So we're going to minus pi r squared times 2. Okay, so that's going to be minus, the r for the circle is 0.25. We have a phone buzzing. I wouldn't worry about it. It could be my phone over there. I don't know. Don't worry about it. Okay. Hey, focus, guys. Focus, please. We're almost done this. So 0.25 pi times r, that's got to be squared, right? Times 2. So what's that? Now be careful on your calculator when you do this. If you do pi times 0.25 squared, 0.25 squared times 2. 0.39269, so 0.3927, let's say, minus 0.3927. Okay. So let's add all this up. So area total should be 4.5 plus 15 plus the area of the big cube. Hey, don't move. Don't move. Do not move until we're finished this. Plus the wraparound part, 5.49778, minus this part right here. Okay. All right. I'll let you guys add that up for the end. You guys can be dismissed. 62.10. Now let's just see here. Plus 15, plus 37.5, plus 5.4977, minus 0.3927. 0.3927. 62.1. I get 62.1. Anybody else get that? Yeah? That's going to be meters squared for the area total. Ah, yes.